Hello everyone, welcome again. This is another of our short tutorials on solar installations, on solar systems. Today we will be talking about or taking some assignments on inverters. All right, remember this is brought to you by Vatfield Tech. I'll be your instructor, I'll be your host, Chukuma Madukwe, as I always do this, as I always take care of these tutorials, these short tutorials and the lectures. All right, so we'll be talking about some assignment on inverters, like I said earlier. So let's look into it. Now, this is the question. If a 48 volt 10 kVA inverter system has a power factor of 0.8, do a system design to find the real power of the inverter system. Now, this is a typical question. Is a question that has so many sides to it, a question that has some challenges that will prove to be very difficult if you do not have basic idea of solar system design, solar system installations, okay, and particularly the inverter system. Now we have been asked to do a system design to find the real power of this inverter system, which is rated 10 kVA, 48 volts, 10 kVA. Let us look into it. Before we can be able to answer that question, let us start by having a proper understanding of some of the technical parameters involved in this. If we really want to have a good study, or if we really want to take care of this problem the way it should be taken care of, we need to look at some basic technical parameters which are necessary, which are required for us to run through this question. Now, as it concerns your inverter system, one of the basic technical parameters you will be looking at is what we call the real power. Then we also have the apparent power and the power factor. These are the three most basic technical parameters we need to have a proper idea of, a proper understanding of, if we want to answer that question that we have been asked. Now, what is the real power? The real power of an inverter system is the actual power of that inverter system. It simply tells you that for an inverter system, the real power is what makes up that your inverter system. It is said to be the usable or useful power used to power up the various loads in a specific facility. What that simply mean in a layman's term, or in a layman's language, is that the real power of an inverter system tells you the actual size of that your inverter system. Okay, it tells you the actual size of that your inverter system, and it tells you the actual power of that your inverter system, or the actual power that will be needed to power up the specific loads of that your facility. Okay, in any way, an extra information, your total load determines the size of your inverter system. So it is the actual power of the load consumption that make up your inverter system, which is the real power of that your inverter system. Real power has the unit of kilowatt, which is what we know as kW. All right, we proceed. Apparent power. Apparent power is said to be the total assumed power of that your inverter system, or it is said to be the imaginary total power that your inverter system can handle. Apparent power is a combination of the real power and reactive power. So when we talk about the apparent power, it is said that it is the total of the real power and reactive power. For the reactive power, we'll come to it. We'll just touch it a little, because the reactive power has little or no significance when we're talking about this your inverter system, in as much as in the real sense of discussing power or energy or electricity, reactive power is very important. But we are limiting these studies to your inverter system. Okay, so your apparent power is said to be the total assumed power. It is said to be the total assumed power in the sense that it can be a larger form of the already existing unit. Okay, so when you talk about your apparent power, that's when you're talking about your kVA, because that is when you see that the uh, unit for the apparent power is kVA. Okay, so the 10 kVA, 20 kVA, 30 kVA, 15 kVA. So it is said to be what we assume that your inverter system can actually power, but it is not what it is. Okay, it is not what it is. Okay, what it is the real power of that your inverter system. Now, the power factor. What is the power factor? The power factor clearly shows you the energy efficiency of that your inverter system. Power factor tells you how efficient that your inverter system can be or is designed to be. How well does your inverter system perform? Depends on the power factor that is used to design it. The efficiency of your inverter system, it depends entirely on your power factor. Generally, power factors ranges from 0.5 to 1. Okay, power factor ranges from 0.5 to 1, but for an inverter system, the power factor is rated to be 0.8 or 80%. An extra information there, or a bonus information there, is to tell you that, or is to inform you that power factor, which is the energy efficiency of your inverter system, or how efficient your inverter system is given in percentages. Okay, which is from 0 to 100%. Okay, so for an inverter system, it is said to be what, 0.8, which is actually 80%. All right, okay, proceeding. Now we want to have a more clarity, to give you guys more idea, more understanding of what we have been talking about. What you have on my screen right now, what you guys are looking at, is a glass of beer. For those of you who like to take beer, like myself. All right, so this is to use this a glass of beer to illustrate what we have been learning so far. In this glass of beer, we have the three types of power. We have the real power, we have the apparent power, we also have the reactive power. Okay, yes, so the real power from the image you can see is the actual content, which is the size of beer or quantity of beer you have in this glass. Is the quantity of beer you have in this glass that makes up the real power, which is what we call the usable electricity or the useful energy. That is the real power. Now, if you look at the topmost part of the image of the glass cup, you will see that the reactive power is what we call the wasted electricity, which is what you can see floating. Those are white foams floating up there. They are the reactive power. We don't need it. It's not useful. It is wasted. Okay, it's like you're talking about losses in your electrical system. Okay, so we don't actually need it. So where you have your apparent power, as you can see, where you have kVA written, is as a combination of both your real power and the reactive power. So as a combination of both your real power and the reactive power. That is what makes up your apparent power, which is your kVA. Your real power is in kilowatt, while your reactive power is in kilovar. Okay, yeah, so I hope this gives you a better understanding of what all the grammar we have been speaking previously. Let's proceed. We are now here to do the basic calculations. In doing the basic calculations, it is also very simple. Okay, so we have been given a question that says the inverter system is what, 48 volts, 10 kVA with a power factor. Okay, so firstly, let us get out the given parameters. What are the given available parameters? the size of the inverter, which is 10 kVA, 48 volt. The power factor was also given to be 0.8. Now, from our previous studies, what is now the apparent power? Using the units, we can now identify the apparent power to be 10 kVA, right? Yes. So what is now the real power of that inverter system is what we are actually looking for. That is why we came for these studies. Let's see. So the real power of this inverter system, or generally the formula for real power, is given as apparent power multiplied by the power factor. Now you know what the power factor is, you know what the apparent power is. What is the real power? Apparent power is 10 kVA, the real power is 0.8. Now 10 multiplied by 0.8 would give you 8 kilowatts. So the actual power, or the real power of this inverter system, is 8 kilowatts. 8 kilowatts. So for you to be able to use this inverter system, you can now know the actual quantity of loads it can power. That is the essence of walking you through the process of getting to know the real power of this inverter system. It means that this inverter system can power up quantity of loads up to 8 kilowatts before it can start giving you those your overloading alarm or error signals. All right, so this is where we would call it a day. This is the end of the lecture on these studies. You can do well to join us for our other short tutorials. You can even take your time to enroll for our complete online course on solar, CCTV, automation, industrial automation, and every other course that we run. You are going to love it. You are going to enjoy it. See you all in the next training session. Thank you.